So in this video we are continuing the topic of model selection and regularization. In the previous video I explained the process of model selection, and in this video I will be explaining the process of regularization. So this is the very small topic that I will be explaining in this video. In the previous video, I explained that there are three different methods of model selection. The first one that we saw was the subset selection, and in that subset selection, there are three different ways in which you can do the subset selection. The objective of the subset selection is to identify the variables that leads to the higher accuracy of the machine learning model. So that was the main objective of the subset selection, and we saw three different methods. One is the base subset selection. The second one was the forward stepwise refinement, and third one was the backward stepwise refinement. So these are the three different methods that I explained in my previous video for model selection. And the objective of the model selection, if there are n independent variables are there, then out of these n independent variable, we need to identify the most relevant attributes or the features that lead to the greater accuracy of the model. Now, today in this video, I will be explaining the method of shrinkage method. As in case of the multiple linear regression, we saw that the multiple linear regression equation is usually takes this form, in which beta 0 is the y-intercept and x1, x2, xp are our input features, and beta 1, beta 2 and beta p are our coefficients, or we usually call it as the model parameters. And the objective of the linear regression method is to identify the line which is passing through all nearest from the all data points, or in another words, we want to reduce this error. Yes. So this error is called as the residual sum of squares, and it is expressed in this equation. The objective of the ordinary least square method or the multiple linear regression method is to minimize this error. So that was the objective. Now, when we minimize this error, what happens is that the parameters that are estimated are using the training data sets, and when we apply the model on a very different test data set, their error is large difference is present between the training error that we have calculated, or we call it as the training mid MSE mean square error, and test mean square error. So these are not the same, and there is variation is present, and that variation is called as the variance. And when we apply the OLS method, we usually face a situation in which there is high variance is there, and we want to overcome that situation. Our high variance situation is also known as the overfitting, and to overcome that situation, high variance situation or the overfitting, we usually use the shrinkage method. And in shrinkage method, we are not interested, or the objective of this shrinkage method is not to uh, reduce the input features, that is x1, x2, x1. It will keep all the features as it is, but its focus is usually to lower the values of beta 1 to beta n to nearest to 0 if the corresponding feature is not relevant. It will not eliminate the irrelevant features, but it will make the coefficient of the irrelevant features to approximately to 0. And this is achieved by changing the objective function. The objective function in usual machine multiple linear regression is the to reduce or minimize the residual sum of square. Now the objective function is a very different term. It has two different terms. The first term is called as the residual sum of square, or the RSS. That is same that we found in OLS method. And in addition to that, it has another term that we call as the shrinkage penalty. This shrinkage penalty is the lambda times sum of all beta j square. Here, all the coefficients are added together and their sum is added to the error term or the objective term. And now our objective is to minimize this objective function. Here, the parameter alpha is known as the tuning parameter, and it varies from 0 to infinity. Now we need to select the values of alpha in such a way that we get the best performance. And when value of lambda is 0, this objective function is same as that of we use in ordinary least square method, and that is to minimize the value of residual sum of square. And when the value of lambda approaches to infinity, the coefficients of insignificant features or irrelevant features approaches to 0. And another objective of adding this second parameter in this equation in the objective function is that as it penalizes if we are going to use more features than necessary. That is the objective of this adding this second term. And if you closely observe, the objective function now has two components. The first component is the RSS, and this first component RSS depends on training dataset. And the second term, that is shrinkage penalty, does not depend on training dataset. And when we use this objective function, our model will perform better on the test dataset, and there will not be much variation in between the training MSE and test MSE, and this variation is called as the variance. And now the ridge regression, which here I am calling it as the ridge regression, will the objective of ridge regression is to reduce the variance so that our model will perform better on unobserved data points. at the cost of bias. Means that now our error during the training phase will be more as compared to the non-ridge regression models. And see here, concentrate here on the shrinkage penalty. Shrinkage penalty is, here we are taking the square of individual coefficients like beta 1, beta 2, beta 3, beta 4, and we are not taking the square of beta 0. Beta 0 is y-intercept. We are taking the square of the beta 1 to the beta n. And why we are taking the beta square? Because if the coefficient is negative, we want to make it as the positive, and that's why we are taking the square. And after making it the positive, we are adding all together coefficient, all coefficient together, and that quantity multiplied by the lambda, which is called as the tuning parameter, is added to the RSS, and that becomes the objective function. So this is about the ridge regression. Now, in case of the lasso regression, which is the second type of regression shrinkage method, in case of the lasso regression, the objective function that we are going to use is slightly different than that of ridge regression. Concentrate here on the shrinkage penalty. The Like the ridge regression, it has two parts or two components. The first component is like RSS is same as that of the ridge regression. But now the shrinkage penalty, instead the objective of the beta, we want in the objective of adding beta together is that we want to make the objective positive one. And while making the positive, here in case of the lasso regression, each coefficient is now taken, the absolute value of each coefficient is taken instead of the square of the coefficient. So that is the difference between the lasso regression and the ridge regression. Now, like the ridge regression, the lasso regression also has the same tuning parameter called the lambda, and this lambda is not applied to the beta 0, it is applied from the beta 1. And here the coefficients absolute value is taken. In case of the ridge regression, coefficients shrinkage, in the shrinkage penalty, the square of the coefficient is taken. So this is the difference between the objective function that is used in the lasso regression and this ridge regression. So here, here on this slide, I am again comparing on the ridge regression and the lasso regression. The ridge regression is a shrinkage method in which the coefficients values, like coefficients values means the values of beta 1, beta 2, beta 3 up to beta n never becomes 0. For irrelevant or the insignificant features, the values of beta 1 betas may approach to the 0, but it will never become the 0. In case of the lasso regression, if a particular feature is irrelevant or insignificant one, its coefficient may become the 0. And that's why the lasso regression is known as variable selection, means that it completely eliminates one of the variable like that we do in the model selection. And it is both a variable selection as well as the shrinkage method. The objective of the shrinkage method is to reduce or shrink the values of the coefficient. Lasso regression is both. It is the variable selection as well as the shrinkage method. While the ridge regression is essentially or purely the shrinkage method. And the difference between the model selection and the shrinkage function is that the objective of the model selection is to identify the most relevant features to improve the model accuracy and the interpretability. Interpretability means that we want to reduce the number of features that we are using in model building process. The objective of shrinkage function is to adjust the coefficients in linear regression in such a way that it will lead to lower variance and better performance on test dataset, or in other words, to avoid the overfitting. So this is the objective. This is the difference between the model selection and the shrinkage methods. That's all. Thank you.